So, good afternoon, everyone, and welcome to our one-on-one Q&A session with FSCV Engineering Design Lead Mukul Jangit and FMEA Lead Mehul Lad. In today's session, we will first address questions submitted via the form, followed by any questions received from the participants on the Zoom session. If we have any time, we shall cover queries from the YouTube web chat as well. So, Mehul, you can go ahead.
Yeah, okay. Hello everyone. So I have went through the FMEA responses. So there is one from Shubham. Okay. There is one from Shubham. Kathy, should I share the screen or is it? Achha, okay, you're doing it. Good. Uh-huh. So there is one from Shubham. Will adding mechanical related FMEA in this document apart from pre-mentioned fields be an advantage or will it be unnecessary? So answering to this question, and adding anything to the document apart from the present lines in the FMEA, it's a good thing to add, but make sure that you guys are thorough with whatever failure causes and references you are carrying out to, because if you feel that it is a necessary failure mode or failure effect, then obviously you should include that, and we can review it and then we will respond to you accordingly. Remaining three from Afrin, the one suggests that I want to find the failure causes. So my suggestion to you will be you find the failure causes on your own. Just try to go through all those modes which have been declared in the FMEA. You will find the cause there itself. There is no need to ask about it. You can go about it on your own. That's what my suggestion is. If you still don't understand, then you can draft a mail and we will look into it. Thank you. That's it from my side, Kathy, for all the FME queries.
Thanks, Mehul. So to all our participants, we will cover your queries if you have any further at the end of the session. For now, we'll go through the one submitted for engineering design. So Mukul will go ahead.
Hi guys, good afternoon. Kathy, is my voice clear?
Yep, Crystal.
Okay, so I think the first question that we have is, do we have to provide simulation outputs for safety circuit or just the schematics? So schematics would do fine. I don't think we'll we'll generally need simulation outputs for safety circuits. But if you have some innovative simulations that you have done and you want to present, or it can give some more confidence in your design, then for sure add it in your appendix. We'll be happy to have a look at it. It will just add a little bit more rigor to your concept. So that will be good. On the second question, are we allowed to implement a traction control system in our vehicle? So this doubt arises on account of rule A6.7.6, says the team member in the cockpit must have full control of steering and braking. So Yash, if you go through the rule book, right, you will see that this A6.7, the entire section is on vehicle movement, and if you read those subpoints in A6.7, you will realize that all of these are for vehicle movement when the vehicle is not on a competition track, right? So for example, when you're moving the vehicle, you're taking the vehicle from scrutineering to maybe the brakes, maybe the brake testing will happen, or where the rain testing will happen, or you're just taking from your pits to somewhere. So I think this A6.7 is on that. So in that scenario, that there should be a team member in the cockpit who should have full control of the steering and braking. I think that's what the rule is trying to say. So it should not be like that a person is standing outside the vehicle and is handling the steering from outside, because that won't be a very good way of doing it, right? It can lead to some safety incidents. But I would recommend that if you have specific doubts on the rules, then you better send it to the rules committee, because this is not really like a rules clearing session, and official responses should come from rules committee. But I think that's what the rule means. Did that clarify your doubt, Yash and Nachiket? Nachiket, you're there?
Yeah.
Okay. So last question is again from Nachiket on, can you please elaborate filter, redundancy, and timing mentioned in the rubric. So guys, this is a point which is mentioned in BMS, AIRs, and IMD. So what it means is, so first of all, guys, this filters redundancy. So it's not filtrate, it's basically filtering, and filtering, redundancy, and timing are all three separate things. And so what we mean by filtering is filtering of the raw signals that you'll get, because there might be certain noise in the voltage signals, in the temperature signals. So you'll have to put some sort of a filtering, probably both hardware and software filtering on your BMS board, so that you can take care of those high frequency noise, right? That is what filtering would mean. So we'd like to understand what considerations you would have taken in your filtering. Redundancy, as the name suggests, right, it's basically if some critical circuits fail on your design, then do you have redundancies for it? So I'll give you an example. So sometimes what happens is that some of the controls on your BMS might be run by software, but if software hangs, right, or if the software goes into some loop and it's not able to come out of it, then there are hardware redundancies built in the system, right? So that is one example of redundancy. To give you a specific example, let's suppose you have a short circuit detection in your system, right? Now, short circuit detection can work both on a software level and on a hardware level, right? So at a software level, it can monitor that if the current goes beyond a certain limit for a certain time, then you, for example, open your contactors, or you disconnect the battery. So that's a software way of doing it. But let's suppose the software is not able to act in time because of some XYZ reason, then there can be a hardware system also in place, which will be the redundant system. So you build uh, layers of redundancy so that the critical circuits will function. So you should decide that which part of your circuit might need a redundancy. Not everything should, because that also adds cost, complexity, and failure modes. So that should be an intelligent decision by you guys. Is that clear now?
Yeah, thank you very much.
Okay. So those were the questions we had, which were posted before.
Yes.
I think, yeah, Kathy.
Yes, so if we can now open the forum to any questions that participants may have, you may use the raise hand feature so that in case, or you may unmute as well. So if you'd like to have, if you have any questions with regards to engineering design or the event itself as well and the FMEA report, please do ask ahead. Let me just check if we have any questions on YouTube. So we have a question from Ketan on YouTube. It's, can you hear me? Sorry, just okay. Yeah, you go. If suppose the BMS is bought from the vendor, how should the teams take care of the software and algorithm side of it? This is not an
Okay.
engineering design question, but yeah. Sorry, Mukul, go ahead.
Yeah. So, Ketan, it totally depends on the kind of BMS that you'll get, right? So there are different kinds of BMS which might be available to you guys, right? Like there might be some design of BMS in which you will be given an opportunity to configure the BMS, in which you can, for example, put over voltage limits, you can put under voltage limits, you can put over current limits, you can put over temperature limits, and all of those things, right? Under temperature limits, some duration related configurations. So usually what can happen is that the BMS manufacturer will expose a method for you to configure the BMS as per your cells, as per your pack configuration, as per your requirements, as per your depth of discharge, as per your current requirements, our requirements, whatever you want to, right? So that is one side of the story. So some of the BMS will work like that. Some other BMSs, depending upon the design you choose, might also open up the entire architecture to you, right? I mean, the entire functionality to you. So you can probably also put algorithms on top of it and not just play around with static configuration. So it totally depends on the BMS that you will choose, that you will find out, right? Or you will choose. But generally, it's a configuration kind from what I've seen. Is that clear? Any follow-up questions on that?
We have a question from Dhananjay. What sort of safety circuitry is required for the regenerative braking system?
Okay, so first of all, you should definitely read the rule book and make sure that all those points are complied, because I don't think it will be possible for me to read out all of them. So that is one. Apart from them, so when it comes to regenerative braking, generally there are 2-3 things you should take care of. First thing would be the overcurrent limit in charging. So your cell manufacturer might have given you an upper limit of how much current you can push into the cells, right? So that is certainly one thing that you should comply to. Second would be your over temperature limits, because during charging, cells tend to heat up little bit more. So temperature limits you should comply to. And of course, when, let's suppose if you are at a higher SOC, like 80, 85%, 90%, then you should comply to the over voltage limits as well, because when you're pushing the current, the OCV, or rather the terminal voltages can go beyond 4.2 or 4.15, whatever is your set over voltage limit. So you should definitely take care of that. These are three top of the head, very basic requirements that you should definitely have. Final thing is, of course, what your motor controller and motor manufacturer also recommends. So it should be in an envelope of all of these.
All right. Thanks for that, Mukul. Participants, do we have any other questions? Otherwise, we have a very short Q&A session then. And I'm assuming that there are 17 of you that joined in because you had questions. So please feel free to ask if there are any. In the meanwhile, I think even Mukul, last year, you did judge the event. Did you have any tips that you'd like to mention to the teams? Anything that stood out last year that you'd recommend to them to do or not do?
Sure. So guys, generally, all of us are engineers here, or want to be engineers, and when we, so sometimes what happens is we get very much carried away with the engineering side of things, and we forget that it's ultimately a presentation, and you're trying to explain what is going on in your mind, what is your concept to a panel of judges, right? So it's very important that your communication right? So you would, although there is a presentation section also which we have incorporated just for that, and it's a very important. So you should definitely make sure that your presentation is in a logical sequence. It should not be like, suddenly there's motor and then suddenly there is cell selection. That would not make sense, because people would not be able to put a lot of concentration into your concept, and they might not understand it. So you should do justice to what your concept is, and the way to do justice is to present it in a very clean way. So make sure you have those good graphics, clean graphics. Don't put a lot of content. Make sure you have a nice chronological fashion, and I'm trying to help you. So if you look at the rubric is also made in that same fashion. So if you follow the same sequence, then it will become very easy for us to understand what you're trying to communicate, and that will be great. Another thing on a technical side is that you should back up your work. So whatever you are presenting, you should make sure that there's simulation behind it, there's testing result behind it, there's some benchmarking behind it, and that really gives us confidence in what you're presenting. So those are like off the top of my head, Kathy.
Great. Actually, we did get a question, and also Mehul, later on, if you have any tips after reviewing last year's FME, we can share that as well. So let's go to Rupesh's question. Rupesh Nair, for systems that haven't been designed yet, is it advisable to showcase a layout that might be very close to the final design on the presentation?
Oh, of course. I mean, that's one of the great points of this challenge, right? This concept challenge, because you are presenting your concept, and sometimes, and in fact, we don't expect that you guys would have completed some of your designs also, because this competition is also meant for teams which are just starting up, right? So we would be very happy in reviewing your concepts, in your schematics, but then you should have enough backup of how you came to that design, right? What were your decisions? What was your top down approach when you came to that schematic? So maybe we will judge on that side, how you reach to that schematic, whether it is manufacturable, whether the design has enough redundancies built around it, whether the design is sufficiently robust or not. So that is the kind of thing we'll be judging on, and of course it should comply to all the rules and it should follow the design intent at a top level. But definitely we'll want to see that.
Okay. So there haven't been any further questions on YouTube. So Mehul, why don't you go ahead if you have a few tips on how they can do better with their FMEA, and if we haven't received any further questions after that, we can end today's session.
Okay. All right. So while reviewing FMEA, I just want to tell you guys that when you go through the points mentioned in the FMEA and when you try to find the causes for FMEA, so or the failure modes, what you guys should do is you should consider both aspects such as electrical or mechanical. So if there is some sensor failure, so sensor can have issues not with respect to just EMI. Consider the mechanical failures too. So once you are thorough with the causes itself, then you can fill out the rest of the columns in the FMEA. Also, one more thing, don't end up mostly the modes which are related to high voltage system or accumulator, everything ends up with either fire or electric shocks or electric arcs. Try to find out a proper effect which is other than that also is which can happen with that particular mode, and then provide the ratings accordingly. Don't provide severity ratings for every failure mode as high or low. You have to make sure that your cause, your effect, and severity are connected somehow. So that's what I'll suggest. All the best, guys.
Hey Mehul, why don't you give an example of one of those effects, right? Like how you mentioned, it's not always shock or fire. I think that will be good for folks.
Mehul, you're muted.
Sorry. So, for example, with respect to the accumulator management system, so most of the people what do is that with whenever there is a set that a BMS is having a failure, or there is no communication between BMS and the systems. So most of the people end with the result that there will be over voltage and the accumulator will heat up, and that might result in fire in the accumulator box. So okay, that can be one of the effects, but you should mention that you will lose your signals, and that might result into some kind of, as AMS signals are SCS signals also, that might result in shutdown circuit and your car will shut down immediately. So you have to consider that while bringing out the effect that there will be fire. So before the fire there might be some condition that it will prevent the fire itself, and you have to take that into consideration. That's what I
Right. Yeah. In fact, for example, if insulation breaks, then IMD would probably detect it before a fire can happen, right? Right.
So we have a question from Samad, and then we'll take a question from HAR above, who has raised his hand. So the first question is, the question is, will you please show, could you please show us what an ideal EDP is and what should be included in EDP, like content and all? Can you explain in brief? Before you answer this question, Mehul, I just want to share my screen. So Samad, what I pulled out is the information rules document, which is on formulabharat.com/FSEV. In here, it is pretty clear, and we've added in a lot more information than previous years as to what it should contain, and this itself should give you enough to start with, especially once the goals and design objectives are very important, and then major points in each subsystem of your EV powertrain. That should give you enough to cover. And as we've mentioned towards the bottom, in terms of submission, is to keep it clean, and judges and even the way when you speak and when you record the video, to not show 20 slides in a second, because the purpose is you're pitching your engineering design. It's important to remember that you're pitching it, and you are imagine that this is a group of judges are actually people who are going to approve your engineering design for an upcoming project, and if you're going to and you have to pitch it to them as to why they should approve the funding for your project. So yeah, I think Mukul, if you'd like to add anything to it.
Yeah, apart from that, you go through the rubric once, make sure you understand what every section means. And I think the rule book and rubric together would give you more than enough information.
Right, right.
So,
Samad,
and
I
there's
hope
nothing like an ideal EDP, right? Because it totally depends on your concept actually. So I don't think there's anything like an idea like EDP.
yeah. So Samad, I hope that answered your question. HAR, sorry, I don't know your full name. You can go ahead with your question.
Uh, Hello. So I had a doubt regarding the severity. So in case we have a short circuit or something, probably our fuse will break or it will be detected by IMD. But in the worst case scenario, it may cause fire and it may lead to heavy injuries. So the first scenario is not severe, and the second scenario is very much severe. So how do we like um, uh, put a rating for that? Should we always go for the worst case scenario, that is like it might lead to a fire and then death, or like it is going to be definitely going to be detected by AIMD, or then it's not going to cause harm?
So yeah, answering to your question, first of all, when you mentioned the failure mode itself, you have to go through your system also. Does your system include an IMD? Does your system, obviously it's in rules, so your system must be including an IMD and also an accumulator management system. So whenever that failure mode is brought up, you have to check that are your protection circuits enough to handle that, and that failure mode will never happen. Okay, so if or it will happen, there's a least chance of that failure mode to be happening, and if there is a least chance of that failure mode to be happening, then you can rate your severity accordingly. But if the failure mode if happens and it's the worst case scenario you are considering, then you can put the severity rating as the highest rating if you want. But then first of all, you have to check that what are your protection systems and how robust your system is before considering that failure mode. I hope that answers your question, or it was not clear yet.
Yes, sir. So what I understood is, if we believe in our safety circuit, then we can put it as a low severity. That is, we believe that it won't cause harm.
Yeah, but even though
That's what you were saying, right? So I had. Yes, sir. Go on.
no, so I was saying that yes, I agree that if you believe in your safety systems, you can obviously rate accordingly, but you also have to consider the uh, occurrence of that failure mode before considering the severity. Uh, was I clear with that? So if the occurrence is high, then
Okay.
sometimes
Sir.
your safety systems might fail.
Yes, sir. So severity is not always the worst case. Okay.
No, it should not be always it should be depending on your occurrence on the other factors. As I said, you have to consider all the columns before giving the severity rating.
Yes, sir. Yes, sir. And sir, can you give an example of what risk might cause death and what risk might cause heavy injuries? But like there is a little differentiation between that. Like,
So when it depends on what you consider as heavy injury. If you are considering heavy injury, then it is basically a term called as fatal that might lead to death also. So both are at the same risk level, basically, for me at least. There is nothing as differentiation between heavy
okay,
injury
sir.
or death. It's a combined term.
So maybe Mehul, one example could be that if the insulation breaks and if you suddenly have like 400 volts on your chassis and IMD is not able to detect that, then that can be fatal for the driver, right? A voltage level of 400. But an injury could be if, let's suppose, there's a fire, and because there's a firewall, then the extent of damage is limited, the extent of injury is limited, but then there are some maybe first degree or second degree ones. So that could be one difference, if that was your question.
Yeah, also you have to yes, exactly
Yes,
what
sir.
Mukul said
That's
is
right.
complete right. Also, you have to consider that the driver has its own suit, which takes care of all the fire cases and which can protect the driver also. So if you are saying your effect, global effect as a fire or the like fire in the car, so you should ensure that your driver has a suit, so it won't lead to a fatal injury. So that time you can rate the severity accordingly.
Sir, in
Uh,
case, well, you are not driving, that is in workshops and all, do we need to consider that cases?
in every time you have to
Like
consider
we are
when
handling the vehicle. Okay, okay.
okay, every time you have to
Yeah.
consider all the cases. That will be my answer. But while you are handling the vehicle, there won't be a driver present in the car most of the times. And whenever your driver is going to be present in the car and you are doing some testing, he should be wearing all the requirements uh, of a driver, such as the suit and stuff, etc. And you guys should also be working with safety equipments. So that's not in the FMEA, but yeah, that's the procedure.
In fact, if you think about it, right, when the vehicle is fully assembled, when all the systems are live, then your vehicle is actually safer, because by just because of the rules and because the way you would have designed your vehicle, the vehicle is a little bit safer. But when you are assembling it, that's where the chances of injury can be higher, right? Because things are exposed, protection circuits are not active, and they can't save like that, right? So only your assembly processes will safeguard you. So you should actually care about both of them ultimately.
Yes, sir. There we get it. Thank you, sir. My doubts are clear.
Great, thank you. We have a question on Zoom and also a couple on YouTube as well from Rahul. In continuation to Samad's question, should the slides focus more on the thought process behind the design, or should we focus more on the specifications that we arrive to after design in the slides? Rahul, if you're
Okay.
here, if you want to elaborate or if you want to clear your question, just to ensure that that's what you meant.
Uh, hello, hello, sir.
Hi, Rahul.
Hi, Rahul.
Okay, so what I meant by my question is, you know, during presentation we have limited time, and also we have to keep the number of slides limited. So, should we focus more while putting content in slide? So, should we focus more on the thought process behind the design, or should we, you know, put that our motor, consider that is motor, so our motor has this much torque, this much, so are those values more important, or is that thought process more important for putting content in the slide?
Hey, that's a very good question, Rahul. I think so. I don't think there would be like a single answer to this, but from what I can suggest you, see, specifications generally would not take a lot of space, right? Because if you finally have to just put out that okay, this is my motor, then maybe you will add like some 6-7 line items, right? Not more than that, because more detail than that won't add a lot of value. So specifications won't take a lot of time, and also in your presentation when you're speaking about it, you don't have to go through all the specifications, right? You don't have to consume your time in going through that because it's already there, we can see it, right? But thought process is important, so it should be a good balance between the two. I would say thought process little bit more, or you're working on how you arrived at those specifications should be little bit more. Specifications just because they would anyway come as a result of your thought process and as a result of your working, your simulation, everything. So and you don't need to speak about them because you can just show them in your presentation. These are my specs, and we can go through that, right? So don't spend your time reading through the specs. That's no use of time. Definitely spend time on how you achieved it, how you arrived at those specs. That will be much more valuable. Is
uh,
that clear? I can give you
yes,
an example if you want. So let's
yes,
talk
sure,
about cell
please.
selection, right?
uh,
So let's talk about cell selection, or even energy, right? So energy is like cornerstone of your whole concept. So when you start your concept, if your energy calculations are not right, then it has like it has domino effect on rest of your vehicle design. So when you're explaining how you reach to a certain energy, then you won't just write that I selected 6.7 kilowatt hour of energy and this is my configuration. That won't really add a lot of value. you still have to mention that, because that's an important number. Ultimately, that's your results. You should mention that. But I would say maybe 70% of your content or more than that should focus on how you reach there, and maybe 15-20% on the final specifications. But both should be there.
Yes, thank you, Mukul sir. Thank you very much. And also for presentation videos, how long maximum time should be there for those presentation videos?
It's in the rules. It's 15 minutes.
Okay, thank you very much.
But stick to it, Rahul. Definitely stick to it.
Yeah.
Plan your presentation well. If required, you take like multiple shots of it, right? Multiple takes you can take, but definitely make a nice presentation which communicates your concept in a very good way.
Yes, definitely, Mukul sir. Thanks a lot.
All right. We have two questions from Vinayak on YouTube. So one question is regarding FMEA failure handling by the team. Do we write for how the team handles the situation, or how they will prevent the situation from happening in the first place, such as while designing it?
Yeah, so answering to that question, the handling part with respect to team is how the team is going to handle if such kind of failure effect is or failure mode has occurred. So it mainly resides on the first point which you asked only, that how team is going to handle that situation, what safety measurements you guys are going to choose, and what detection methods you guys are going to include for that particular failure mode.
And the next question from Vinayak is regarding the wiring harness section of the presentation. What are the best ways to showcase the wiring of the vehicle? Do you expect us to provide a schematic, or a block diagram is enough for explanation?
Okay, so schematic would be great, because, and I think schematic would come in your LV system architecture, because you will show how your different modules are sort of connected, right? You won't go to details of your harness. But see, it's a very I mean, you can use it to your advantage, right? So for example, when it comes to harness, there are two parts of it, right? There's an electrical design part of it, there's an optimization part of it, and then there's the entire mechanical part to it also, right? So if I was in your place, and working in the industry, working in Formula Student, I know that harnesses are very critical, right? Because harnesses are exposed in a lot of places. Harnesses are literally like spinal cord of your vehicle, right? If harnesses break, then your vehicle can't work, however good your battery is, however good your LV system is. So I would probably like to focus on how you have made sure, or how will you make sure that your harness connectors are good, your crimp qualities are good, your wire insulations are good, you have like good conduits around your harness, you have made sure that you use minimum number of wires. Maybe if you use like a CAN bus methodology, then you can minimize the number of wires. Then good quality automotive grade connectors you are using sealed connectors. You are ensuring that there is adequate strain relief given to the wires. And probably how your harness is mounted and routed in your vehicle, and is not just susceptible to driver damaging it while riding your vehicle. These are the kind of things I would look at. So it would be a combination of packaging, combination of routing, mounting, design, strain relief. It's up to you guys, right? How you want to showcase your concept. But ultimately, what you want to see is how you have designed the harness to make sure it's reliable, and it harness ultimately is a dead weight, but it enables your vehicle to perform in a robust way. So you have to showcase how it does that, right? If you can ask me a follow-up question if you want, but if it's not clear.
Okay. We'll wait for Vinayak to
Right.
message back on that. In the meanwhile, Nikhil had a question with regards to failure handling in a vehicle. Nikhil, are you here? Nikhil Thosa?
Yes, ma'am.
Yes, go ahead with your
So,
question.
yes, ma'am. Sir, I have a doubt regarding failure handling vehicle. Sir, at times there are many circuits in a vehicle which take necessary actions, but at times we rather use indications to the driver for certain failures. So, can we include it in the failure handling vehicle where driver takes a necessary action by that indication?
Can you just provide an example? Which failure mode are you referring to, or something like that? Where did you find that?
Sir, so for sometimes the connection is not complete, but the values, the sensor values differ, and the driver knows it by some indication. So, sir, can we include such type that driver will take necessary action against it in that section, field handling vehicle?
So failure handling vehicle majorly depends on what your vehicle is going to respond with respect to that failure mode. For example, an SCS fault has happened, the shutdown circuit will be opened and your car will stop. So that is what your vehicle has the response to that particular failure mode. If you have provided an indication and driver is going to respond to that particular mode, so I guess you just can mention that there is an indication provided, but that is not the failure mode handled by your vehicle itself. Your vehicle has, so you can mention that there is an indication provided to the driver. That's it. But make sure that is it necessary, because as far as I have experience, there is no such case there where driver has to like do something to remove the failure while you are on the vehicle itself.
Also, to add to what Mehul said, right? Something like a COV, CUV, over temperature, over current, definitely these are governed by the rule book as well. And you would not want a driver to take an action because A, there can be a delay, B, there can be a mistake, and all of this will lead to high severity kind of a failure mode, right? So, and a similar thing is like for a ground fault or even for an interlock failure, these things are driven by rules. So in those scenarios, definitely, I don't think drivers should take an action. This will also be mentioned in the rule book. There might be some secondary sensors, right? For example, let's suppose you have a yaw sensor on your vehicle. You have a inertia, not inertia sensor, but you have like a yaw sensor or an IM or an IMU kind of an application that does not directly relate to the safety of the vehicle, then probably you can give that to the vehicle, but not for the primary sensors where it is related to safety and it is governed by the rule book.
Okay, sir. Thank you. That was helpful.
Mukul,
But
so
read
Vinayak,
on this.
sorry,
Okay.
continue.
Yeah.
Yes, sir.
No, I'm saying that read the rule on this. Is very clearly mentioned, I think. If not, you can write to the rule.
All right. So
Yeah,
Mukul,
Kathy.
Vinayak has responded to his previous question on the wiring harness. So his query was, so do you expect us to have those design considerations and those in design consideration and not in CAD, right? Since CAD and the rest of the assemblies will take time as of time of the presentation.
Sure. So definitely, I don't think that you might all the teams might not have the CAD ready, and that is acceptable. But you might want to say that okay, I'm planning to use AMP seal range of connectors, just quoting a name, or I'm planning to use T range of connectors, and these connectors are automotive graded and they have strain relief built in them, they have waterproofing built in them, they are vibration resistant, and this is how, and they also come with a mounting feature. One side of the story, right? Second story is that we plan to use these harness clips across our vehicle so that the harness stays routed, stays mounted. There are no, forces acting on the harness. That there is this kind of a conduit we are planning to put. These are the kind of things that you can still put, right? Because these are conceptual things. You can say that this is generally you have positioned your components around the vehicle so that your harness is sort of optimized. Those are the things you can still put and won't require a CAD. And maybe even insulation ratings, even wire gauges, right? Those are the things you can still design for.
Okay. Right now, so there are no other questions on YouTube. If there are there any questions on Zoom? Any participant has any further queries? If not, we can go ahead with ending today's session. Okay. Vinayak says thank you. And I think, all right, guys. Great. So I think we'll come to the end of the session. Mukul, Mehul, thank you so much for your time. And to all our participants, thank you for joining in today. You have a wonderful Saturday evening and good luck with your preparation towards the FSEV Engineering Design event. Looking forward to your submissions. Yeah, thank you,
Thanks
everybody.
a lot, Kathy.
Thanks, Mukul. Thanks, Mehul. Have a good day.